I'm honored to be in front of you today, helping share Syracuse energy efficient designs, mixed use, multi-family building C. Our lot location is in the divided city of Syracuse, New York. More specifically, a quarter-mile away from the university on the McKinney Manor, on the other side of this tremendous barrier, Interstate 81. Like Interstate 81, the infrastructure on this lot is crumbling. This is our lot, 101 Latimer Terrace, and it's going to be the focus for massive, multi-million-dollar redevelopment in the coming years.
So we are Syracuse Energy Efficient Design. I'm Erica.
I'm Noah.
I'm Mike. I'm Ben.
I'm Ryan.
And we represent a multidisciplinary team of 22 students from both SUNY College of Environmental Science and Forestry as well as Syracuse University. We began this competition way back in September where we hung flyers around campus to try and get students to join us as an extracurricular activity. We told them this was an opportunity for them to give back to the city that's housed them for the past 4 years or so. It's a chance for them to take what they learned in school and apply it to the real world. We met with our industry partners over time and held a few charrettes and got feedback from them as well as bounced ideas off of each other. We began this competition eager to do our part in the transformation of Syracuse, and this is how we did it. So displayed on the screen are the goals that our team believes to be the most essential to our design. Before making any decisions, we brought our ideas through these touchstones, starting with environmental impact and ending with replicability. We asked ourselves, does this decision lead to net zero energy? Does it promote a healthy lifestyle? Is it affordable? How resilient is this option? How easily maintained and operated can this option be? And how easily replicable is this option? So we will reference these touchstones on the screen throughout the presentation using this panel on the left. If the touchstones are dark and highlighted as they appear here, it means that the decision on the screen directly relates to that touchstone. We also not only use basic codes and standards like Energy Star, LEED, and Net Zero Energy Ready Homes, we also use Syracuse-specific initiatives. We couldn't ignore the fact that Syracuse is being rezoned or the ideas that Purpose-Built Community puts forth towards fighting poverty. So we met with Syracuse city officials and had meetings on how to introduce these ideas into our design. We also met with our current building owners of our lot, Syracuse Housing Authority. They helped us with operation and maintenance costs of our building as well as the effectiveness through their experiences. They taught us and helped us with creating an innovative building as well as making it practical. We also discussed with them our intended occupants. Through intensive market research, our goal for SEED is to include a 61% market income and a 39% below market income. Included in this income rate is professors from the universities, doctors from the hospitals, young professionals, and single-parent families. We also included these occupants based on the location of our lot. We are within close proximity to the hospitals as well as both universities. To tackle economic and social problems, the mayor has set forth the Syracuse Surge, which is $200 million dedicated to revitalizing Syracuse's infrastructure. Syracuse Housing Authority also put forth their transformation plan, which is to help diversify and densify the area. Currently, they own 118 acres on 27 blocks of the East Adams Street neighborhood. On these 118 acres is McKinney Manor, which is where our building will be located. Shown on the top right of the screen is our building lot, in yellow highlighted. That lot will be split into 3 parcels in order to reintroduce the city grid. Our building will be a mixed-use, mid-rise building, which will help broaden Syracuse Housing Authority's housing stock.
So, as Erica stated before, we will be located on the lower lot of McKinney Manor. So we designed the site specifically to promote this outdoor activity, the active design for the residents and for the commercial space. So some of the key elements we include are picnic areas on the circular images there on your left, as well as a community garden and a playground for the commercial space. With that, we also have designed a rain garden, not only for aesthetic value, but also to limit the discharge into Syracuse's outdated combined sewer system. So essentially the sewer system, in times of heavy flow and rainfall, will take and combine sewer and stormwater runoff and dump this into Onondaga Lake, which is the nation's most polluted lake. So to limit this, Onondaga County has realized this issue and has begun promoting green infrastructure practices throughout the neighborhoods using the Save the Rain program. This program has won the United States Clean Water Prize back in 2013 for combating these issues through their initiatives. To continue pushing for this, we cited other green infrastructure practices around the site. So these include bioswales along the outline of the parking lot, stormwater planters along the outline of the building, and porous pavement on areas susceptible to rainfall. All these systems were designed for the 90th percentile storm, which is about 1 inch in Syracuse, and then any extreme events will go through overflow drains in each practice, going to a corrugated pipe detention basin located under the parking lot. This will limit discharges in times of high flow and ensure that we push towards the revitalization of Onondaga Lake and endorse the healthier city environment for the city of Syracuse.
You're right. The space is extremely functional, but it also has aesthetic value. We were trying to make this space act as a unifying area for the neighborhood. Since Syracuse is covered in impervious pavement and concrete, we wanted to accentuate the amount of green space that exists on our lot. So you can see there's a pergola with a fire pit in the front of the building for the residents, as well as a umbrella section with a grill. And obviously, you could read our project report under there if you wanted to on a nice sunny day. But the architectural design really started with the units, and it helped drive the shape of our building and its hallways. This unit right here makes our building shape on the bottom lot, and because it's so simple, it can be easily transformed. It can get longer, it can get taller, it increased the number of floors, it can also increase the type of function. Obviously, we chose the bottom space because we wanted to accentuate the amount of green space. However, the Syracuse Housing Authority wants to house 200 people on these 3 parcels that's going to get cut up. And so ideally, our net zero building will be on the bottom. So the middle parcel will be turned into a residential community. And the top one, which is on the busy East Adams Street, will be turned into a business district where the commercial flag takes over the entire frontage. Although the units are simple, it doesn't take away from the aesthetic value of the interior. How many of you guys have heard of biophilia? Yeah? Okay. So, Michael Green probably defines it best. He's a mass timber architect. He says humans have an inherent attraction to the outdoors, and so having earth tones on the walls, products with a grain pattern, and natural daylighting at the forefront of every space really accentuates the space, and it gives it characteristic appeal before it's even furnished.
So our building sits at 5 floors with about 57,000 square feet. Here you can see our 1 and 2 bedroom units converge to both define the interior and the exterior of the building. This offsetting effect allows us to eliminate a typical issue in some buildings, which is this uninterruptible hallway like the one seen in the movie The Shining. Here we break up the space and allow us some areas of storage for our occupancy's primary form of transportation, which would be bicycles.
In addition, we also have 1 and 2 bedroom units on our ground floor in order to account for the 80-20 ratio set forth by the Department of Energy guidelines. Between our units and our commercial space is what helps Siege function. We have properly sized operational rooms, like a mechanical room that can house not only our equipment, but also our operational staff in the case of regular maintenance and operations and emergencies. We also have a trash room, which is sized towards zero waste guidelines, so we have trash chutes and receptacle bins that can be easily carried through a separate doorway directly to the dumpsters as seen on the site plan. Our commercial space is also designed with safety in mind. You can enter the vestibule outside of the weather, but you cannot enter where the interior of the functioning space will be.
I don't know if you want to cliffhanger. The commercial space, although we're not required to pay one for the competition, we chose a daycare, Seedling Daycare. we were in between a coffee shop, we wanted to choose a gym, but the need for a daycare was at an all-time high in the Syracuse community, specifically East Adams Street neighborhood. Over 75% of the families living in this area are raised by a single parent. So obviously the needs for trustworthy, affordable, well-kept daycares are at an all-time high. Not only does this design meet the New York State daycare requirements, but it also goes above and beyond by introducing design critiques from a Harvard study. The Harvard study is the 9 foundations of a healthy building, and they say that a healthy indoor environment provides positive, it does really good things for the kids. It helps their cognitive ability. And so we took these practices and implemented them into our design. So we have natural daylighting, an abundant amount of lighting for reading, compartmentalized wall assemblies to reduce the amount of noise, water filters at every sink and drinking fountain because the lead in this area is kind of a problem. And then we also have a playground which accentuates active design.
So you all may be wondering how this building will be constructed. It's important to first note that all of our wall materials have been designed to be panelized. Therefore, we can do several things. We can increase our construction schedule or accelerate our construction schedule. We can also ensure the utmost quality of our prefabricated wall sections, which can be fabricated year-round. In addition, this reduces construction waste. Starting at the foundation, our foundation stem walls and first floor are constructed out of insulated concrete forms. This allows us to have a podium-type construction, which is extremely resilient and allows our building to have a prolonged lifetime. In addition, the above-grade walls are constructed out of 2x6 frame walls with cavity insulation as well as exterior rigid insulation. The entire building will be cladded with an ultra-high performance concrete panel, which adds to the resilience factors that we've been identifying for this project. In addition, we ran our building envelope through a 2-dimensional software known as Therm. Therm allows us to do a couple things. The most important thing it allows us to do is identify the temperature within our wall cavities. This is given at the worst case scenario with a 0 outdoor degree temperature and about a 70-degree temperature on the interior. We are able to identify the weakest points within our building envelope, which is actually seen here in the middle drawing, right where the ICF connects to the above walls. We can identify that point, and we can identify the temperature at that level. This allows us to identify whether condensation has a potential of forming within our wall cavities, which we realize is a detrimental issue to buildings. Also, we went with a very innovative strategy for air sealing the interior of our apartments. This is not our primary air sealing approach. This is simply our compartmentalization approach. So the idea here is we use a product known as AeroBarrier, which is an aerosolized solution that is misted into the apartment. While this is all going on, we are also pressurizing the apartment. This forces the small particles to target the cracks in our building envelope and seal them up, as seen in this image here. This product has been named by the National Home Builders Association as the most innovative product in 2018, and we felt it was perfectly adaptable to our project.
In addition to compartmentalization, we also use source control when considering our interior materials, finishes, and products. This is important since our touchstones are indoor air quality and a healthy lifestyle, because our occupants do come first.
So, continuing on with our indoor air quality, we have a central ventilation system that will serve the residential and common spaces such as lobbies and hallways. So these airflow rates, based on ASHRAE 62.1 standards, as well as Passive House guidelines, will come up through these central ventilation shafts located throughout the building to a central unit as a Renew Air HE Series ERV. So this will essentially be equipped with a MERV 13 filter and then resupply the air back into the units. So we made sure not to pressurize the units again, just to ensure the units stay safe. So from there, the commercial space, we're going to use an innovative new ERV unit, which gives you real-time sensing of VOC concentrations of CO2, as well as temperature and humidity control. so we can ensure the highest comfort for our daycare. This will all be controlled through this duct sealing technology known as AeroSeal, which is similar to what Michael discussed, which essentially just seals all of our ducts with these long duct runs to ensure we're not losing air throughout these runs. So this sealant has a very extremely low VOC concentration. As well, we can see results 25 to 30 years out after this process is completed. So these ERV units will actually be supplying air back to the return of the heat pumps. So these heat pumps we chose are the Daikin Smart Source water air heat pumps. These will be a decentralized design, so each unit will have its own heat pump. This is equipped with a COP of 3.13 and an EER of 34.2, and was sized based on a modeling software called REMRate, which Michael will discuss later. Which came out with an output of about 3/4 to 1 ton systems. This is dependent on the location of the unit throughout the building, as well as 1 to 2 bedroom units. The diagram on your right shows our typical duct layout for each unit. So we made sure to supply air near areas where we're expecting heat loss, so areas near the window, as well as supplemental return, so we're not pressurizing the unit. These heat pumps will be powered through our ground source wells. So these will be 400-foot vertical wells located throughout the site of our building. So this glycol mixture will be sent through by 2 10-horsepower pumps into a central geothermal manifold, which will then distribute the glycol mixture to each unit's heat pump in its own separate maintenance room, and we then will be servicing the water-to-air or water-to-water heat pump for domestic hot water production. So for this, we went with a centralized design for our domestic hot water. And I know you're thinking, we went through PASPAL's guidelines and we conducted all these decentralized designs. But we noticed a common problem in this industry is upsizing of heat pump equipment. So in order to do a decentralized design for domestic hot water, you'd have to accompany a desuperheater on a heat pump, which would upsize the equipment by 3-fold of what we expect the heating load in our building to be. To accommodate for this, we did the centralized design with 2 11-ton water-to-water heat pumps with 200-gallon water heaters in order to service the residential and commercial spaces. This will be sent through with insulated 4-inch pipes into our units, which will be consisted of a tight water core to limit any heat loss within the pipes. On the end of each of these branches, we have water sense fixtures, which we expect to get a result of 47.5% water reduction from lead baseline. So this will be an example for buildings around the area as well to incorporate this in saving money on their water usage. Any design, MEP design, is incomplete without lighting. So to simulate day lighting within the unit, we used a DIVA simulation, which is an add-on for Grasshopper software, which configures optimal day lighting, uses changing around window-to-wall ratios. So we came up with an optimal window-to-wall ratio of 19% for each unit, going through worst to best case scenario, as you can see here with the red showing where we expect day lighting to be. Also with that, we utilize this software to place our artificial lighting within the unit, not to overlight the unit, and to show where we should incorporate dimmable light switches, so near the windows, so that way the residents can have more control over where they want their lighting. For common spaces such as hallways, we have a Carlton lighting system, which is given to us by our sponsors at Tatum Engineering. So this is an occupancy zone sensor system. So after 5 minutes of being in the hallway, the lighting system will dim down to 20%, which leads to a 73% savings over traditional T8 fluorescent lighting systems. So this will help definitely with our conservation of energy throughout the building, as well as ensuring safety for the residents, making sure that the hallways aren't dark while they're running through them, making sure it's all censored.
One of the hardest, most nearly impossible variables to calculate in a high-efficiency building is the building occupant's behavior. In order to combat this, we're going to be using techniques of demand-side management. We have constructed a demand-side management manual that will inform residents of how they can further their energy efficiency and be more eco-friendly. Along with this demand-side management manual, we will be providing weekly seminars that will inform building residents about how they can make strides to live a more green lifestyle. We understand that everyone is not going to be interested in reading the manual, so this is why we are offering these seminars. We will also be using an active system known as Siemens Desigo. This Siemens Desigo system will be used to control all the systems in the building under one easy-to-use roof. This graphic on the screen right now shows all the components that will be involved in the system. Although it seems complicated, it is very effective for operations and maintenance. The Siemens Decigo system will allow the superintendent of the building to easily identify problem areas, and it will also function with the residents to inform them about how their actions are impacting the efficiency of the building and their energy bills. It is a very easy to use system and can be simplified if the resident chooses not to take full advantage of it, although we do encourage them to. Since this is a solar decathlon, what kind of team would we be if we did